Coming up, we continue the tradition of answering questions no one was even asking. In this installment, how fast can the Commodore 64 and 128 download data using period-correct hardware? I'm Matt D'Amico, and welcome to episode 77 of Retro Bits. Back in its heyday, in order to transfer data to our C64 from a remote source, we'd most likely be using something like this 1200 baud Commodore 1670 modem. It connects to the machine by way of the Userport. The Userport is a general-purpose, programmable interface managed by the Two Complex Interface Adapter, or CIA chips. One common use is for serial communications with a Commodore-specific modem like this, or other hardware interfaces that convert the system's TTL voltages to RS-232 levels. The main issue with the Userport is speed, or rather, the lack thereof. As designed, the interface is stable at speeds up to 1200 bits per second using the built-in kernel routines that implement a CPU bit-banging technique. A software-only hack saw 2400 BPS speeds achieved in 1989. Almost a decade later, in 1997, 9600 BPS was demonstrated using a hardware and software hack that utilized both CIA's shift registers and timers. So how long does it take to download a single floppy disk worth of data? The 1541 is a single-sided, double-density drive that can store 170 kilobytes. At an ideal rate of 1200 bits per second, it would take around 19 minutes to download one full disk. In the real world, however, transferring data over a phone line is far from ideal. Line noise causes corrupted data, requiring blocks to be retransmitted. RS-232 itself isn't 100% efficient, as control bits are sent over the wire too. Transfer protocols have their own overhead like checksum bits. We also have to deal with slow storage devices. In testing, the average transfer rate over a 1200 baud connection was 672 BPS, about 34 minutes for a full disk. Clearly we need more speed, and thankfully there are options for that. This is a Turbo 232, or rather a modern replica of one. They were originally designed and sold by Dr. Evil Labs, then later by CMD. They implement an RS-232 interface with a proper UART, something the 64 and 128 didn't have from the factory. UART stands for Universal Asynchronous Receiver Transmitter. As the name implies, these devices are used for exchanging serial data between two computers at various transmission speeds and data formats. UARTs buffer and serialize parallel bit streams and provide the necessary timing essential for integrity and synchronization of the data. One example is the MOS 6551, which can be found on the Commodore PET and the Plus 4. The C64 and 128, however, are not so equipped and are thus limited to lower speed transfers. The Turbo 232 also implements the MOS 6551 and provides a standard 9-pin serial port. By offloading work to the UART on the machine's cartridge port, much higher transfer speeds can be achieved than those seen by Userport devices that scrape by bit-banging the CPU. Here's the test setup. In order to remove the old analog phone line and modem from the equation, I've connected the Turbo 232 through a no modem adapter and gender changer directly to my laptop with a 9-pin cable and a USB serial interface. The free StrikeTerm software provides several transfer protocols supported by the Commodore terminals we'll be using. This should give us a good idea of the maximum transfer rates that can be achieved. Of course, there are multiple ways to attack the problem, such as stepping through the code and counting clock cycles, but I've neither the time nor the skill for that at present. For me, the fun is messing around and trying stuff out. I've created a test file containing 32 kilobytes or 128 blocks of random data to use as a benchmark. In StrikeTerm, I'll kick off the first test by initiating the sending of said file. Now on the Commodore, I'll start the download using Y-modem. I'll be using this transfer protocol for all subsequent tests because it uses a larger packet size than X-modem and should yield better performance at the high port speeds we'll be trying. Z-modem is also an option, but in my testing it wasn't as reliable, possibly due to its streaming nature and the lack of hardware error correction in my test setup. Here, the port speed is 9600 BPS. Look at how much faster it is. See the big pauses between each block? 3 guesses as to why that is. Figured it out? That's right, at 9600 BPS, the limiting factor is now the slow 1541 disk drive. Without acceleration, the IEC bus limits read-write performance to a little over 2400 BPS, so the faster port speeds offered by the Turbo 232 are wasted when transferring files with this setup. So here are the performance results using line speeds of 1200, 2400, and 9600 BPS. Notice that at 1200 and 2400, actual performance is about 50% of the line speed. Protocol overhead and disk access slow everything down. At 9600, the transfer is only 20% efficient. At even higher speeds, any performance increases become vanishingly small as disk access holds everything up. Clearly, we need even more speed, and thankfully, there are options for that too. The RAM expansion unit, or REU, is the next piece of the puzzle. The disk drive is slow, but a RAM disk, now that's another story entirely. This original Commodore unit provides an additional 512K of nearly instantaneous storage thanks to its DMA capability. But how can we use it when the Turbo 232 is already in the cartridge port? This is the Xpander3, one of several port expansions that let us connect and switch between different devices and cartridges without having to constantly plug and unplug things from the back of the machine. Power and control lines for each of the 3 ports can be independently enabled or disabled by way of dip switches. While not very common, it's also possible to have multiple devices using the expansion port at the same time, so long as they don't conflict with each other. If the devices exist on different base addresses and don't try to use the same control lines such as GAME and XROM, they can coexist just fine and be used simultaneously. For the C64, we'll be using StrikeTerm, which is based on NovaTerm, something I used myself back in the day. Both support the REU, so we need to set it up by entering the buffer menu with F7. Next, we need to select the memory device by pressing K. There are a number of options here, including using the C128 16 or 64K of VDC memory, even though we're in 64 mode. There are also options for GeoRAM and CMD RAM link in addition to our Commodore REU. Now we have half a megabyte available for scrollback and file transfers. If we hit A, we can see the contents of our RAM disk. That's 6 times more space than a 1541. Nice. After saving the configuration and restarting StrikeTerm, all that's left is to change the upload-download device from the 1541 to the RAM disk. The secret here, and this is undocumented, is to type the letter B for buffer. It will show device 7 instead, but trust me, this works. Time to test. First up, a repeat of 9600 BPS, but this time to the REU instead of the disk. Already we can see a huge difference in that the delay between blocks is much lower than before. And done. We'll take a look at how the speed compares in a second, but first let's verify that the file is on the RAM disk. Okay, the file is there, which is great. Of course, if we want to use it, we still need to copy it back to the disk, which is a slow process. For today, we're only interested in the theoretical maximum here, not actual usefulness. That said, this setup could have been viable for couriers back in the day who needed to move files between multiple BBSs as quickly as possible. So how did downloading to the REU compare to the floppy drive at the same line speed? Wow, now that's more like it. The bottleneck is gone, and the transfer completes 3 times faster. This is good, but let's see if we can do better. We're really cooking now. Can we go any faster? The answer is maybe. At 38.4K, the transfer was unreliable with Y-modem. It may have to do with the 1KB block sizes used by the protocol. I retested with X-modem and that worked. The X-modem protocol uses a 128 byte block size and is less efficient. At 38.4, it was slower than Y-modem was at 19.2. So it looks like we've hit a wall with this setup. Higher speeds are absolutely possible on a C64, but more drastic measures like blanking the screen would be required in order to achieve them. Let's switch to 128 mode now and fire up DesTerm. This is my favorite terminal from back in the day, and it's easy to see why. It really gives terminals running on more advanced systems like the Amiga and IBM PC a run for their money. At boot up, it automatically detects the REU and will make it available for us to use. All we have to do is go into the Disk Functions menu and assign the REU to a drive letter. I'll pick drive B. Next, I'll format the REU as a RAM disk. Once I select the appropriate drive, I can display the contents of the RAM disk. Here's a pro tip that took me a lot of trial and error to figure out. To copy data between drives, the syntax is lowercase drive letter, file name. It seems obvious, but use uppercase or omit the drive letter or colon and it'll fail silently. Anyway, if you want to preload files into your RAM disk or move downloads to a floppy later on, this is how you do it. Finally, let's assign the download drive to B: so we can run our benchmarks. At the same port speed, is the 128 any quicker than the 64? Yes, it is, and I suspect with twice the CPU power, we can go even faster. Wow, we doubled our line speed and almost doubled our throughput. What do you think? Should we push it even further? Yeah, of course we should. Interesting. We upped the port speed by 50%, but only saw a 33% increase in throughput. That's still impressive, but I think we're running up against the hardware limits of the system. My suspicion was further confirmed when I attempted to download at 115,000 bps. Just like the 64, Y-modem became unreliable. X-modem worked, but at a lower throughput than Y-modem at half the port speed. So, what conclusions can we take away from this? Well, first, the jump in throughput when taking the floppy disk drive out of the equation was massive. Of course, there are other ways around that are still period correct, including Jiffy DOS or even a hard drive. The jump from the C64 to the 128 was also impressive, demonstrating how much the CPU, and to an extent the VIC-2 chip, matter to the overall throughput. With this particular setup, the C64 attained its maximum throughput at 19,200 bps, while the C128 saw benefits all the way up to 57,600. To put this in perspective, that's an entire floppy disk worth of data in 48 seconds, a far cry from the half an hour it'd take with the 1200 baud modem. Bear in mind, this was not an exhaustive test. Different transfer protocols, serial interfaces, and terminal programs may yield different results. Faster speeds can and have been achieved on the C64 by blanking the screen to free up more CPU cycles. At the end of the day, this was just a fun experiment to try and not a serious scientific endeavor, so take these results with a grain of salt. So now we have a reasonable idea of how fast the C64 and 128 can transfer data using a regular terminal emulator and period correct hardware. What can we do with this newfound knowledge? I don't know, put it on YouTube, I guess. I hope you enjoyed this bit. Thank you so much for watching. Happy downloading, and we'll see you next time.